Good afternoon. This is the 6 degrees of cross-site scripting exploitation talk. I don't have a good pronunciation for whatever XSSploitation would be, but we thought it was clever. The talk is going to focus on cross-site scripting and the combination of that plus native code vulnerabilities. I'm Dan Moniz. This is HD Moore. You've seen HD Moore and the other 2 previous talks he's given today, of course, from XSSploit. To give an introduction of what the rest of the talk is going to be, we really focus on conversation in the talk as opposed to having a lot of slides. The primary reason being that this talk is really sort of a proof of concept kind of talk. I started doing this with an OWASP talk that I was asked to present in April in San Jose in California. And I had to come up with a topic. And one of the topics I was thinking about was MySpace. Specifically, I was thinking about cross-site scripting and the problems that cross-site scripting has, and also the fact that there are very few case studies of really interesting cross-site scripting exploits, except for Sammy is my hero and MySpace. So by a show of hands, who is like vaguely familiar with the Sammy is my hero hack? Sweet, you're all in the right talk, great. So it's basically just me as one guy who thought it was an interesting topic. And when I gave the talk at OWASP, I was trying to think about, okay, I can talk about a case study which is Sammy is my hero to a bunch of people who may not be as familiar with it as people in this community are. But you know, what's new to say there, right? And luckily for me, HD Moore had done a whole bunch of work on a tool called Hamachi, which he released at CanSec West, just before I gave the talk at OWASP. And I wasn't actually at CanSec West this year due to other obligations, but having heard about it and it made the news, of course, it's everything. By the way, HD just got on the front page of Marketplace in the Wall Street Journal. So, I mean, clearly, the guy makes news, right? He's a rainmaker. So I heard about Hamachi, I knew about HD, and so I was like, well, that's interesting. You know, fuzzing browsers just with DHTML and finding bugs that potentially are exploitable. Combine that with cross-site scripting, and what the Sammy is my hero hack does specifically is combine cross-site scripting as a broad category of vulnerabilities in web applications with ridiculously popular sites, right? And that's not a factor of cross-site scripting, that's just an artifact of MySpace. And MySpace, not to pick on them, it's just this is what happened to happen, right? I mean, it could be any other popular site. MySpace just happens to be really good at their job. So that's what we say. It's basically using cross-site scripting in concert with ridiculously popular web content as a viral infection platform. That's really the idea, the kernel of the entire talk. And so why do we talk about this? Are we out to make life horrible for people who run really popular websites? No, we're not. I mean, honestly, we're really not. What we're trying to do instead is to think about how attackers with criminal motivation and profit to be made, and there's a lot of them out there that are currently using cross-site scripting, which we get into in a little bit, is a problem. And people, you know, again, this is the common thread, right? Think like an attacker. That's what we always tell people who are in IT security who don't necessarily interact with the hacker community or the black hat community. And so that's really what the talk's about. There we go.
So first off, anyone who does exploit development, the first thing they're going to say when they hear about a cross-site scripting vulnerability is, why does this matter? No one freaking cares about cross-site scripting bugs. I mean, what was the last time you saw a cross-site scripting bug show up on BugTrack you actually cared about? Most people I know believe that cross-site scripting issues and kind of these like crappy low-end web vulnerabilities should be pushed off to their own, dedicated list, so the rest of us don't have to sort through them all day. But the reality is people can actually use these things for, make money and exploit things and integrate with other products, or excuse me, with other attacks. And that's really what we want to talk about today. It's not so much how, cross-site scripting is bad and everyone's vulnerable, but how you can actually use that as a platform to doing more interesting things. Rich content's become a huge thing lately. Any website that tries to allow the user to provide, some kind of rich content like bold tags, smiley faces, injection of images, Flash applications are a big one. Also opens the door for things like cross-site scripting and kind of like forced browsing and taking control of any user browser that happens to visit that control of that site. It affects, all this widely deployed software, everything from, Blogger allows you to inject JavaScript stuff in style tags, not Blogger, WordPress. And just about any of these web applications and forums have at least one way you can bypass JavaScript filtering to inject, arbitrary scripting code. And people are actually using this now to make money by doing things like drive-by malware installations, where they actually abuse cross-site scripting bugs in combination with things like banner ads and forums and blog spam to automatically install malware and make money off people who actually visit these sites. So that's really why we think it matters and kind of where this talk is going.
So to start off, what we wanted to do initially was to do sort of a review of major cross-site scripting vulnerabilities that people have heard of, that people know about. And my personal interest was in picking ones that have a lot of detail in order to explain them to an audience which generally doesn't really get into the nitty-gritty of these things. This is not that audience, right? I mean, as by the show of hands, clearly people are broadly familiar with the SAMI hacks specifically. But to go over it in brief, so the SAMI is my hero. I won't really call it an attack. I mean, I don't really believe that he meant it as an attack in any real sense of the word. But MySpace was the target, right? It was an attempt to tweak MySpace and to fiddle with what he could do. The injection was via cross-site scripting. The actual attack itself performed both cross-site scripting and then also cross-site request forgery, which is the ability essentially to make requests across sites without necessarily injecting script content, which gets to be sort of a key point later in the presentation. The payload is entirely JavaScript. There is nothing in his code and in the actual SAMI is my hero hack/worm that is not JavaScript. It is entirely JavaScript. It is self-replicating code only. By virtue of being JavaScript, the only thing that this does is replicate itself across, in the case of this particular hack, individual user accounts in MySpace. Now that's, by saying only, I'm not saying it isn't important. It's very, very important. But by saying only, what I mean is that there isn't anything other than just simple JavaScript code that's going to run and execute in the browser. So if you can constrain the amount of JavaScript that runs or constrain the type of JavaScript that runs, that would affect the ability of this to propagate. But it is notably JavaScript that self-replicates on a site with around 70 million vulnerable users. So, 70 million is kind of a large number. And these numbers are sort of my guess. The last published information I have for MySpace was that they were around, I think, 30 million registered users, million members, whatever, around October, or around the time he did this. And then they later came out with a statistic saying that they add around about 5 million new users a month. So I just kind of, aggregated over time and kind of allowed for different things to happen.
So the way that SAMI works is interesting because it's not just, stupid cross-site scripting. A lot of people don't care about cross-site scripting because they don't realize what you can really use it for. Cross-site scripting, when people, especially in the security community, demonstrate it, is usually a little script tag that pops something up showing your cookie or showing that it can redirect you to another site. And while that's a really good demonstration of, a quick demonstration of what JavaScript injection can do, it's not really the extent of it. SAMI worked by putting a style tag onto, or excuse me, a style parameter onto a div tag that told it to execute a JavaScript chunk of code. That chunk of code was encoded using the decimal to ASCII conversion stuff that's built into JavaScript. And from there, it actually created the XML HTTP object to basically forge requests from the client back to the server. And that's important because once you can do arbitrary XML HTTP requests from inside the browser, you are that user's browser. Anything that user currently has access to on that website's context, you can do whatever you like to on the site. You can post to forum variables. The only thing that you really can't do at that point is something that require like image verification from the user. And even still, there's ways to forge them and typing it in for you. So at that point, you are the user's browser. You control all their settings. If the SAMI decided to if the SAMI worm targeted the authentication or the password change form, they could actually reset everyone's password of the entire website instead of just doing, just propagating from profile to profile. Or installing something that after a certain time would run, like looking at using the JavaScript date command or date function. I mean, there's a lot more evil things that could have happened with this that didn't happen, but the key point is once you have that type of injection, any sort of JavaScript inclusion into a browser, you have full control of that user's browser in the context of that website. And your limits are, whatever the limits of the website happen to be.
And just to, before I move on to this slide, I just want to reiterate exactly everything he just said in terms of the real issue here is that you have a programmatic interface to control everything the user would normally do themselves transparently, right? Really one way to think about this, and this is a bit of hyperbole, is really the ability to do XML HTTP requests behind the user's back is like back orifice for all websites everywhere, right? If you think about it, if you can talk behind a user's back and automate pretty much everything they can do while they're already authenticated on the site, you own them. For people, anybody here attend Jeremiah Grossman's talk? Anybody see his talk? A couple of people have? Okay, great. He did a talk, notably our talk, if you looked at the presentation descriptions, they seem a little similar. His talk is excellent. If you haven't talked to him or if you haven't seen it, I definitely encourage you to read the slides and check out the details. Basically what he talked about with TC was essentially JavaScript, pure JavaScript code that he injected via cross-site scripting to essentially create a scanning and vulnerability assessment platform inside the browser. And his target is internal corporate networks. right? This is not that, but it is very important to point out. I made the whole rigmarole earlier about it's only JavaScript, but that shows you exactly what you can do with JavaScript, right? You can create essentially, you can replicate 70% of Nmap and then other things, and then look for other ownable browsers, which you can also own through XML HTTP and other behind-the-scenes methods.
And the further we go into this with, actually operating systems, that people also talk about eventually making your operating system a website, or using, Web 2.0 technology. I don't know if that's trademarked or not, so I probably shouldn't say that. But Web X.0 technology.
O'Reilly may be upset with you.
Right. Okay. Well, I can run fast, so. So when basically using all this behind the back scripting interaction with the website to basically create rich user interfaces, rich applications, and kind of full operating systems the user can browse to. Well, what happens when you have a cross-site scripting vulnerability in your web OS? When you have all your personal documents, all your finance documents, everything else you have is now stored on that website, and the second you have a single cross-site scripting vuln, all that data becomes exposed to the user. So whenever you hear anyone talk about how great this Web 2.0 crap is, and how you'd love to see an operating system that's built into a web page, kind of point out the JavaScript and the cross-site scripting issue, because it's so easy to steal all that data. Sorry, that was kind of.
No, that's exactly what we're trying to talk about, right? I mean, and that's really where this is, right? I mean, he just mentioned Web 2.0 and the idea of having all of your documents in one place. And as he's saying this, I'm thinking to myself, this sounds an awfully lot like, I don't know, Gmail. Google Desktop.
The Google platform.
I don't know.
Yeah.
Not to say, I mean, this is not like, and we're not saying that we're looking to target those people, that we have code that works against like Google Desktop or Gmail or anything like that. But really, it is the metaphor, right? There's a lot to be said about putting everything on the web and making it universally available. But obviously the trade-off is now it's universally available, right? There's obviously like a certain cutoff point at which there is like a cost-benefit analysis that has to be made. So another example that I wanted to mention just briefly is JS Yaminer. I'm going to say it's Yaminer. I don't really know if there's a proper pronunciation. But very briefly, this was just a simple, I won't say simple, but this is a cross-site scripting vulnerability that hit Yahoo Mail. And the only reason we really bring it out in this particular instance is though Yahoo Mail is not what I would normally consider a viral site, and I get into my definition of viral later, but I just wanted to bring it up as another example of like MySpace. In this room, who uses MySpace or has checked out MySpace for non-Sammy related reasons?
We won't laugh at you.
Yeah, seriously, I'm on MySpace, so I'm first among the guilty. Okay, a few people, not very many, but a few. So MySpace doesn't necessarily ring very loudly with a lot of communities, especially the corporate community, right? I mean, however, webmail, broadly applicable in translation, in internationalization to something like 70% of the world's audience, i.e. Yahoo Mail, right, does, right? Because either they use Yahoo Mail themselves for the ability to send emails to people outside the corporate firewall, or they know somebody who uses Yahoo email, or they understand that a webmail application is a webmail application is a webmail application. And in this case, JS Yaminer basically it's a really simple kind of attack, but basically it allowed them to gather credentials from people who are logging into Yahoo Mail. Right? I don't get into any more detail than that. There's plenty of stuff to look at. It is not as detailed as the Sambi worm, but it does go into a little bit more than I'm going into here. Now, I'm going to hand it off to HD to talk about this unpronounceable one, but this is really, the thing I want to highlight before I hand it over is just, this is really the first, I'll call this like version 0 of what we were thinking about. This happened after we put this talk together. This happened like, what, last week, 2 weeks ago?
Yeah, a week and a half ago.
Week and a half ago. So like we're talking, HD is in Texas, I'm in California, and so we're talking and we're trying to get everything together, and then this happens. And it's great for a certain reason because it points out exactly what we're afraid of, and that this is the harbinger of. Because one thing I will mention is that, again, the talk is a combination of cross-site scripting, viral sites, and browser vulnerabilities. And WMF is not a browser vulnerability per se, but it is the harbinger of native code exploits distributed over web content, like exploited web content. So with that.
So WMF is old news, right? Does everyone agree with that? It was back in January, no one really cares about it anymore. Everyone who's really worth their salt's already patched. Auto update in Windows XP, who cares, right? The problem is you still get a 1 in 10 ratio right now if you actually try to hit random users with it. If you set up a website and all you do is serve WMF to them, 1 out of 10 of those users will actually accept it and it'll actually execute code on their system. And that number doesn't come from any kind of sanctioned white hat test. That comes from some folks in kind of the European drive-by malware install underground that actually gave me some numbers when I asked for them. The Browser Fund project kind of shook out a lot of things with regards to the economy of the malware installation industry and kind of how that whole process works, how much money there is to be made, and how well these types of older attacks still work. So in the case of WMF, 1 out of 10 people that they hit out of sites that have 30,000 to 40,000 users a day are vulnerable to this, and that's what they use to install malware. So it doesn't really matter if it's patched, it still works well enough that they don't see a reason to change anything else. In this case, someone hijacked one of the Flash banner ads for, was it? Yeah, it was one of the Flash ads that was part of MySpace, and Flash has the ability to run arbitrary JavaScript via this getURL function. And getURL basically takes whatever URL you put into the parameters, hands it back off to the browser, and that URL could be a JavaScript tag to do something else. So in this case, they did a JavaScript getURL tag that redirected them to another Flash application, and that Flash application then redirects them to a WMF file. The WMF file then automatically installs a piece of malware, and the guy sitting in the back makes 40 cents per hit that actually installs. So someone made a ton of money off this, and they actually, the numbers the media reported based on a counter built into the application was 1 million people were hit with this in the period of a week using this banner ad on MySpace. Now, some of us can figure that if you're browsing MySpace, you kind of deserve to be hit by WMF, but that's just kind of, you know.
I wasn't going to say it.
If you're not patched to WMF and you're using MySpace, you kind of had it coming. That's all I'm saying. But in this case, I mean, it really shows like how the economy of scale applies to older vulnerabilities and things like cross-site scripting vulnerabilities in Flash. In this case, it was like 16,000 page views per day, according to Alexa.
Yeah, so this number is a little, I mean, obviously this number is a little hard to interpret. This is, he had the metric of 1 million within a week. There's a couple of numbers here at work. I'll break them down in a little bit. So MySpace, if we assume MySpace roughly, and people who work at MySpace can feel free to correct me on this, but roughly 70 million users around nowish, maybe a little bit more, maybe a little bit less, right? MySpace itself, according to Alexa, right, which is a quasi-reliable source of trend data for very popular sites. It doesn't apply to every single site on the web. If there's any marketing people in the room who are maybe are attending with other people, if your Alexa rank is really, really high number and you jump 400 points, that doesn't mean anything, because statistically it only really counts for a certain number of sites. I can't tell you how many. So the metric that Alexa has for how many people see MySpace is around 16,000 page views, so 16,000 MySpace page views per day per million users of the web. All right, so I mean, if MySpace has 70 million registered users already, right? So I mean, it's 16,000 page views per 70 million users, so 16,000 times 70 times 70, essentially, per million. And then every other number of the web. We tried to find reasonably good statistics about numbers of users on the web who either have, in the way of counting is weird, because it's either who has web access, who actually visits the web, who has a browser, what browsers do they use, blah, blah, blah. But basically, if you assume there's something like, I'll throw out 500 million users of the web, which is, I think, roughly accurate, I mean, to a degree of magnitude, right? 16,000 page views times 500, right? That's basically the number we're looking at in terms of how many people saw MySpace. How many people may have seen the actual ad is a little bit different, but he mentioned 1 in 10, right? If we just take MySpace users, 1 in 10 is 7 million, right? And then if we
40 cents, so I made a lot of money.
Right, and so basically this is the economies of scale, right? Of course, there's an economic advantage here, so it's all about economies of scale. You want to mention Flash 9?
Right. So the solution to all this was to add a new parameter tag to every Flash tag that's embedded in a web application, saying whether or not this allow networking tag can be used. And if you have allow networking equal no as the parameter for your Flash object on the web page, it basically says you can't do getURL, you can't do this JavaScript redirection, things like that. What they didn't really take into account is it only applies to Flash 9. If you haven't upgraded Flash, if you're using Linux and you're still waiting on Macromedia to get off and release, Flash for everybody else, then you have the same issue. Like, cross-site scripting is a fun issue because people who use Mac OS X or Linux or, God forbid, OpenBSD and get on their high horse about how wonderful their operating system is, it doesn't freaking matter. If you have Flash and you have Mozilla, you're just as screwed as everybody else. And in this case, it was WMF, so it's not directly applicable, but in terms of web application hacks stealing data, there is no difference. I mean, I could browse Yahoo Mail with my Firefox on Linux, a hardened kernel, and an OpenBSD sticker on the back to make it go faster or something, and it still wouldn't help. I mean, but yeah. So the point is, if you're not using Flash 9, none of these solutions for Flash-based cross-site scripting injection actually apply to you. In the case of, there's actually another case that's related to Google, where it wasn't Google themselves with AdSense, but it's somebody who resells AdSense basically and allows people to do Flash banner ads that eventually lead to an AdSense click. They have the same issue, and they have a huge install base. They did the same solution to it, which is the allow networking tag. But anyways, that's kind of where things stand. That's kind of where things stand right now. The allow networking tag really kind of annoyed us because when we're putting this talk together, that was kind of our silver bullet. That's like, okay, well, it doesn't matter how great you strip out anything. If you allow Flash, you're screwed because of this get URL function. But because of the MySpace hit with the WMF stuff, they added this tag, and now all of a sudden, that part of our talk had to go out the window. So
yeah. Oh well. I mean, in terms of talking about the realm of bad things, the ability to, a part of our talk getting trashed in exchange for less vulnerabilities in Flash, so much the better. Notably, again, this was a WMF vuln, this particular case, so it doesn't necessarily apply to Mac OS. But so people may ask, well, how many, where's Flash 9 available, as an example, right? And it's not available on Linux yet, as far as I know. I mean, they could be making lives out of me right now. But notably, I'm running this on a PVC PowerBook. I'm old school right now. I don't have a MacBook. Notably, Macromedia has not released, they have not updated past Flash 8 for Intel MacBooks. So, I mean, I don't want to harp on MacBooks either, because I hope to get one soon. But if you've seen Johnny Cash's talk with David Maynard about, they kind of pinged the Intel MacBooks as their particular example in their wireless fingerprinting, driver fingerprinting. They are also vulnerable to this same attack. There is no version of Flash 9 which you could get the benefit of the allow networking flag. So it gave some very brief overviews of some large cross-site scripting kinds of vulnerabilities that we've seen in the wild. These are all things that have been seen in the wild, right? The WMF one being the most recent. From our perspective, how do we want to make, in the context of this thought experiment turned into a talk and turned into a concept, like an attacking concept, how do we want to make cross-site scripting useful, right? What do you have to do? Well, we want to combine cross-site scripting injection with native code exploit payloads. That's really the idea. That was the genesis of the idea. And all it was me trying to figure out what cross-site scripting and viral propagation of JavaScript meant if we could combine things like HD's Hamachi and bugs that you find through things like Hamachi, et cetera, in browsers. Now, luckily, again, I didn't have to do much work because HD put together a thing called Browser Fun. Who's seen Browser Fun? Who hasn't seen Browser Fun? All right, all of you, write this down, browserfun.blogspot.com. If you can go there now, but please look at it. It's very, we're going to show you a screenshot in a second. But so once you combine cross-site scripting injection, all well and good, right? You have something, which in this case we hope is some kind of native code exploit. We wanted to use the Flash and WMF, and then actually, instead of using WMF, we were going to use a browser vuln. But we wanted to have some kind of native code exploit payload in the site. And then we want to propagate that same payload across sites or across a very popular site, ideally, with cross-site scripting, right? Or cross-site request forgery, either or. And then we want to hook into the browser. So we have essentially, instead of just running JavaScript code to repost the same code, which we would also have, we'd also have an actual native code exploit for the browser. And then you want to hook into the browser, and then you want to go to the next web application, and then you want to try to essentially inject yourself into that next web application. Right? So there's a little bit of heuristics here, right? We're trying to say, go to something like MySpace, get owned by our browser vulnerability, and then transparently your browser will, as you browse around, find other potentially vulnerable sites because the code is just running hooked into IE. And so as you're browsing around, it'll look at what essentially we look at as form variables. Right? HDR has some code that looks at form variables through IE hooks. And so if you're going to blogger.com and it sees a comment form, it will automatically inject to test and see if it can get cross-site scripting code to go in there, right? And then if that works, we can also essentially just propagate the same thing. And the whole idea, the whole kernel of this is now you have essentially a unpatched, direct, unguarded route to massive native code owning, basically, right? I mean, that's really what it is, right? It's like all we're using cross-site scripting and the web for is the viral propagation mechanism. People like their interweb, right? It's a series of tubes, so I mean, who can't like tubes?
This is kind of the A-bomb for the blogosphere, if you want to call it that.
Yeah, exactly.
As soon as so far, web application vulnerabilities have always been like little islands where each application, you can't really escape. If you can infect everybody in MySpace, well, there's a whole lot of users, a really big island, you get them all, but you're still stuck in MySpace. Now, what if you look at smaller web applications, the ones that don't have, quite as much effort going into stripping out JavaScript, or those little standalone blogs, or all those, horrible little blogging engines that people use on $10 a month hosting sites. None of those things strip out JavaScript worth a damn. They just expect the person posting to control what they post and basically strip out JavaScript from comments, but not from actual posts. So this allows you to basically, anybody who browses your island gets infected, has their browser infected, and then from that point, anywhere they go and post comments, post blog stuff, post their own blogs, send out email, anything they use with their browser, in the case of email being webmail, would then propagate the same code to those other islands. So you go from being able to take over just one little node to being able to take over just about everything they touch, everybody else they interact with. So you find a very prominent blogger, hit them first, and if they're doing 15 comment posts a day, you have this nice viral spread all the way across the blogosphere, whole thing melts down, and the rest of us who hate blogs can go, yay! Sorry, I don't really hate blogs that much, but...
No, clearly.
Yeah. So this is a screenshot of the Browser Fun website. The goal behind this is basically to describe what types of bugs affect modern browsers, how they work, and how you can demonstrate them. And what it ended up becoming was 31 days of 0 day. So we started off every day, and for the first 2 weeks, I basically had a big list of bugs I had already reported to Microsoft and other vendors. And I was just going down the list, basically dumping them out. A lot of cases, the vendor was already working on a patch, or the patch was already done, but going through QA. Or in the case of Firefox, they had already released a patch for it. So it wasn't really a big deal. But around the 12th or 13th, I kind of got sick of doing the same old bugs. So you know what, let me just find a new bug every day. So starting around 10:30 p.m., I started just digging for bugs. And then around 1 or 2 a.m., I posted a new one. And that happened from probably mob number 12 to mob number 31. So most of those bugs are still pretty fresh, if you want to call it that. Congrats to the Firefox and Mozilla development team for getting a remote code execution bug fixed within about 30 minutes after figuring out exactly what caused it. It just took 8 people and 4 days to figure out what caused it. But anyways, I got a t-shirt, I'm happy. So yeah, Browser Fun was fun. So Browser Fun was kind of like the recent project that I worked on, but a lot of people doing drive-by malware installs are already using other known vulnerabilities. For example, the MS06014 bug uses an ActiveX control to basically create any other object. The way ActiveX security works, especially with regard to the object model and what you're allowed to create and do from an ActiveX, is there's only one layer of filtering. If you can load an ActiveX control, and that ActiveX control allows you to do something, that's it. That's the only security check. So this particular control had the ability to create any other object on the system with whatever privileges that the user had. So it didn't really matter what other security measures you had. If you could load this known good MDAC control and use RDS.data control to create any other object, you can use this to basically create the wscript.shell object, and from there install and download malware and all that. The IE, one of the, I think it's like either the second or maybe the 8th bug I posted, this HH control one, is an ActiveX control that had a heap overflow, where you keep setting the same property of an ActiveX object over and over and over again, it eventually corrupts the heap and leads to code execution. And at the time I was like, oh look, another heap crash, whatever, dumped it out. And about 3 or 4 days later, a managed security service provider contacted me saying, hey, we're actually seeing this already in the wild. I'm like, wow, that was quick. It took 3 days for someone to go from, a post in this stupid blog to a working code execution that uses a heap overflow. And they're like, no, it actually started back in January. Like, huh. Well, I'm glad I reported it. Hopefully it'll get fixed soon. So it's actually being used in the wild to do drive-by malware installs already, even when I went around to posting on the Browser Fun site. So if you find a really good vulnerability in the browser, more than likely someone's already abusing it. So that's kind of the issue. Also, there's another issue with a really similar problem to MS06014. If anyone installed the WMI software development kit, it installs another object called WMI.objectbroker 2.1 that has the exact same vulnerability as MS06014, but only applies to developers. So if you're targeting a development-centric organization, you can just create this object and then use that to create any other object and own the browser in 10 seconds. So that one's still not patched. Hopefully it'll get patched eventually, but it has like a 1 in 50 ratio, so it wasn't really a big deal to the people I knew that were already exploiting it when I found it. So native code hooks. First of all, why did we bother targeting IE? We all know bloggers all use Firefox. Why don't we just target them? Well, MySpace users still use IE, so we figure, if we take down MySpace first, we can work on the bloggers later on. But I'm sorry. So I just like I think MySpace is the new AOL. But that's just my opinion. Sorry, no offense, but
it's fine.
All right, so IE is really neat to hook because it's really easy to hook. All the HTTP operations that happen in the Internet Explorer browser go through basically inetmon.dll. So there's a single DLL, and if you want to basically hook every single post call or every single GET request made by Internet Explorer, it's only a single function you have to patch. So it's real quick, real easy, bam, done. It still has, 85% market share and going down, but until then, it's a really good vector for this type of attack and this type of hook. There's 3 places you can hook an IE. One allows you to do things as basically hook all post requests and GET requests. Another one allows you to basically hook all responses from the server. And another one allows, I think it's before the user types into a form, you can hook anything they type. So basically, it's really easy to hook IE in these 3 different places to capture all data someone types in the browser, hook anything they send from their browser to the internet, and hook anything the internet sends back to them. And that's actually what we decided to use as the point proof of concept for injecting JavaScript code through the browser. With IE7, it actually kills active XSSploit, so we'll have to try a little bit harder in terms of finding new bugs. Hopefully, it did a good job. We'll find out pretty soon. And who's familiar with the recent Mozilla/Firefox extension backdoor that folks talked about recently? Okay, so there is a website distributing a malicious extension for Firefox that basically captures all your form data. It was called password manager or some kind of benign name. But when you install that, anything you type into the browser, then you use the documented extension API to save all that stuff off and send it off to some other guy. So credit card information, order information, all that fun stuff is being sent off. So those same APIs can be used to hook Firefox the same way we're hooking IE with native code. And probably a lot easier because you can write it in Zool or whatever they call their programming API, as opposed to having to do it all with real code.
So in terms of, a potential implementation for how this would look, right? I should mention up front that we don't have a demo per se. We're going to show code, but we don't have a demo because, one, we really were banking on the Flash, the ability to use the whole Flash exploit, and God damn it, they did their jobs. So kudos to them. I'm glad that they actually fixed it. On the other hand, this is more of the thought model about how this would work, right? So notably, this is suboptimal for a real worm in a sense because ideally what you want to do is, we're targeting IE purely because of market share, right? I mean, it's got the largest possible number of users on the internet, in terms of using a browser, right? And it may change, but it's not there yet. It's suboptimal for a real worm because we do hard code some limitations, right? There isn't a lot of heuristics. What it basically is code that looks for form variables and associates them with a certain type of site, which it has some notion of some kind of injection that will work, right? So ultimately, again, if you want to spread out from the individual islands, you start to have to add essentially signatures, cross-site scripting exploit signatures to the code in order to be able to inject into multiple sites. Now, one other way you could get around that is to actively have a database of people contributing things like elsewhere, which is potentially something that somebody might do. I mean, I don't think you'd see it in a large community. What you might see it is again in the spyware and in the adware community, right? They may create, I mean, as HD mentioned, a lot of the times we can target something like MySpace, which is really, really popular, or we can target a general piece of technology infrastructure that is also very popular, like Blogger or like WordPress. Each individual WordPress site or install may be slightly different, but they're all running the same infrastructure, right? So it's almost like better target. You do more island hopping because you can just get around to every single WordPress install everywhere, right? So with those limitations, we don't have any real obvious elegant solution for that yet, but I'm sure somebody will come up with one. So in this case, what we're thinking about is something like a blog and IE as the target, right? So targeting a blog in terms of the actual web content we're going to try to inject into, and targeting IE as the browser to hook into, right? Specifically, we want to look at comments and trackbacks, because comments especially are often unfiltered. And you see this especially because who here has ever seen blog comment spam before? Right? I mean, who's had to deal with blog comment spam? Right? So, I mean, it's an obvious problem, right? Filtering this stuff is hard. And a lot of it is because you have restrictions on the basis of names, canonical names. Like you can say, oh, well, only people from certain domains can post, or I do a CAPTCHA, or whatever, right? It's not very good. Trackbacks are even worse because trackbacks aren't generated by you, right? What happens generally in the trackback is that somebody else submits information which then gets posted on another site, as opposed to going to a comment site where the information you post is still there. Trackbacks essentially migrate content to and from sites automatically. So you can look at a post, like I could look at a post if for instance, BrowserFun supported trackbacks, which I don't believe it does. You could go to BrowserFun and then you could see somebody else posting about BrowserFun on some other blog on the BrowserFun blog. Right? Not as a comment, but as they just made a post, it got synchronized via RSS and the trackback API, and it's there, right? And so I guess we'll go into it for now. Okay. You can go into this. Or actually, do you want to handle this? Or? Go for it. All right, so the exploit lifecycle, in terms of, if that's the setup, if that's the environment, the petri dish that we want to live in, what's the lifecycle look like, right? Well, this is where I get to define my definition of viral, right? Vulnerable web content, site or software, Blogger, WordPress, or MySpace, Zanga, whatever. Preferably something that's not only popular, but has a viral growth curve. And viral growth curve is important for true kind of drive-by pwning, because what we're talking about is any site where the average is that it adds more than one user for every user it adds, which is kind of recursive, right? But what it basically means is if I added HD to pleasepwnme.com, right, and he only added another person, that's not viral, right? We're just linearly growing one by one by one, right? Ideally, what happens is that every single person adds more than one person the time that they add. So then you have this curve which slowly gets exponential, right? And that's what you want. If you're a marketer, or if you're a site like MySpace that has mostly advertising revenue, or Zanga, or any other similar site that would be applicable here, that's really what you want, right? You want a viral growth curve, because it's more users bringing more users. And that's also great for us, because it means we have more eyeballs always refreshing every single time, right? We don't have to become stale with linear growth curves or with people who patch or whatever else, right? We can try to mitigate the 1 in 10 kind of issue.
So we're going to take a little bit, a quick look at some of the code we use to do the injection, in case anyone cares about the guts of it. Hooking into IE is real easy. All you have to do is basically patch the DLL at runtime, and there's lots of ways to do that. Anybody who's used Ilfax hotfix for WMF, or Alexander Sotorov, hopefully I pronounced that correctly, hotfix for one of the recent vulnerabilities. I think he also did WMF, but there's another vulnerability previously he also patched. It's the same thing. Basically, you want to hook whenever a new application is created, you want to load your DLL into the process space, find the code in question, patch that code so it does something else, and in their case, block a vulnerable function. In my case, automatically capture all post requests and modify them in transit. After you hook the actual browser, you want to actually look at the content of the post request, fingerprint that, figure out what application they're currently posting to, and if you don't recognize it, pick a generic method that will probably work for that application. Or decide that, hey, I want to be stealthy, I'm just not going to inject into this one. Eventually, we have application-specific code injection. So for something like WordPress, you have to use style tags to use JavaScript injection. Or something like Blogger, if you can find a way to inject cross-site scripting stuff there. Or to MySpace, the comment spam or email, whatever happens, whatever you want to do there as well. The easiest way to do this, of course, is via JavaScript include. Basically do something that eventually writes a script source include and basically stick all your code onto a third-party site. The disadvantage to that, of course, is once that site goes down, your virus doesn't work. So you need to find better ways to distribute your code, and whether that means compressing the entire thing and sticking into one big JavaScript chunk and injecting that into every post. There's a really good way to do that. What we've seen so far is because just storing your code on a third-party server works so well, there hasn't really been a reason to change that. It takes people such a long time to take down a server hosting malware that even if you only have a 3 or 4 day gap to launch your worm, it's still enough to make enough money to retire and buy an RV or whatever you want to do with it. So we're going to look at the code up for a second, and then we'll probably go into Q&A stuff. So if anyone cares, this is actually a complete rip-off of Ilfax WMF hotfix, just kind of a demonstration of how to repurpose code. So we look for win9net.dll. Is that actually readable from anywhere?
Yeah, people in the back, can you see this, or can I make the font larger? Larger? All right, let me make it larger quick. How is that? Is that readable in the back? Yeah? Okay, great. Go ahead.
So the first thing we want to do is find every module named win9net.dll. Hang on. Getting used to the whole Mac keyboard again. Boring. Page down is a strange place. So first we want to, find the address we're looking for. In this case, we're looking for, where's the N key? It's just hard to find, sorry. So if we actually look at the memory for HTTP send request A, that function, and win9net.dll, we'll notice that for the most part across every version of Service Pack and every version of Windows, it's about the same. Push EBP, move EBP, ESP, push byte, push some dwords, do some stuff. So basically the prefix for this function is about the same. There's a couple changes in XP, but not too many. But it's pretty consistent is my point. Like, if you patch it one way, it'll probably work in every other system with a couple modifications. So all we do is basically replace the very beginning of the function in memory to jump to our code instead. And that happens in this block, hook start, where, keyboard. There we go. So we find the address, we change the permissions of it to be, page execute, read write. Then we patch it with our code that basically causes it to jump to our function instead. And here it is. So we make it a jump instruction, then we make it a relative jump to the DLL in the memory based on the offset. Kind of standard stuff for hooking, not very exciting. And finally we get to our code that actually hooks the function. So anytime you post to any web page, this little block of code gets called. And all this does is a little assembly stub that just takes the arguments that are currently passed to it and pushes those onto another function that does the filtering, which is this. So here we see, we've got different flags. If there's no data in the post, we just ignore it. If the data is longer than basically 0 bytes or more than 0, then we actually look at it. And here we do fingerprinting for, like, say, blogger.com. This is actually an old copy of the code. So it doesn't actually have the logic. It just has the notes in it. So we see the word post body anywhere. We realize, okay, this is the blogger.com post. We know how to bypass it based on these kinds of embedding. Restrict script tags, comments are stripped from all GS content, but we can probably inject JavaScript someplace. I think it's my other code that actually has the details on that. Then we have WordPress. So how do we detect WordPress? We look for WPN1's variable, we look for the user ID, the variable, the post, things like that. And where is the actual post data? There you go. Content, bling, bling, shallow, bling, blong. Okay, now that was actually just test content so I could find it. But so you look for the content variable followed by the post title, you realize, okay, this is WordPress, we need to inject it a different way. In this case, all we're going to do is replace every one of the posts with new var equal, script hello from XSSploitation. This is a really boring version, but this is my old code, not the stuff we're actually still working on. And that's basically it. So tiny chunk of code that does patching. All you have to do is basically anytime a new application starts, you have to load some code that finds the DLL, patches it, jumps to it, and so on. And you can do that via the app init DLLs key in the registry. So anytime a new process starts, you automatically hook that process. So simple stuff. It's the same way most malware works, the same way most hotfixes work. But now we're using it here for automatically hooking all IE posts. So eventually when we have this cleaned up and less ghetto and less verb off of ILFAC, I'll post the code to the Metasploit website.
That's exciting. So, I mean, one question to ask, obviously, is like, okay, you just saw the code that we hook into IE. How did you get it in there in the first place? Like, we did, 31 days of 0-day vulnerabilities, right? To start with at Browser Fun, right? So people are already doing this, right? HH control is already being used. People are already doing this kind of thing, right? They're doing it less well than we are positing here, but I mean, I wouldn't be surprised actually if we've been beaten to the punch a long, long time ago. Right?
I mean, the easy shellcode for all these vulnerabilities is to run some shellcode that downloads an executable and runs it executable. That's the easy way. That's what a lot of people are using now, and it works really well and it's effective. The nice thing about doing it that way is you can use the non-shellcode type vulnerabilities, the ones where you can do create object and MSO614 and the WMI SDK bug and so on. You can use those to use the XML HTTP object and ADODB stream to download an executable, then run it locally. So the same method works for both. Once you have the exe then installs all the hooks into memory, modifies the registry, and so on. And that code's actually already finished, but there's no point distributing it until the actual attack code is done.
Until we can pwn.
One of the nice things about the Month of Browser Bugs project is there's a ton of Internet Explorer vulnerabilities, so most of those are related to ActiveX objects, or they weren't really exploitable in the normal sense, they're like a null dereference, so most people look at the list and say, hey, this doesn't really matter, it's a freaking null dereference, why are you posting this crap? And we got a whole lot of those, and that's fair. But come August 8th, I think, is next patch Tuesday, there's a really fun bug that's going to be released that basically allows you to turn any unhandled exception in Internet Explorer into code execution. So that goes from being 20-odd null dereferences to 20-odd ways to run code. So if you made fun of the Browser Fun blog for being full of null dereferences, you're allowed to, but now those actually become useful starting next week. So expect advisories and fun and chaos and all that fun stuff around then. I think we're good for questions, right?
Yeah, so that's all. We're open to take questions. These are some websites and links to our email addresses. Metasploit, of course, is the place to look at. Browserfun.blogspot.com for all your browser fun. Any questions? Let's get them. Come on up or just shout. Come on, it's not the end of the day yet. You can't start drinking quite yet. You have one more presentation. Come on. All right, thank you very much.
Thanks.
Appreciate it.